In section 12.1, you saw that one way in which a limit can fail to exist is when a function approaches a different value from the left side of c than it approaches from the right side of c. This type of behavior can be described more concisely with the concept of a one-sided limit. So here is our c value here. So the limit of f of x as x approaches c from the left equals L sub 1. And it can be written in this way as well. We usually see it in this way here in this textbook. Now this is the limit from the left. The limit from the right, then you have the limit of f of x as x approaches c from the right equals L sub 2. So let's evaluate one-sided limits. Find the limit of f of x as x approaches 0 from the left and from the right. So I have a graph here. It is helpful to graph. We have f of x equals the absolute value of 2x over x. So first of all, we know that if we plug in 0, we're going to get the indeterminate form 0 over 0. So let's just plug in some numbers. So let's pick some numbers to the left of 0. So we know it's never going to be on that line there. Let's try f of negative 1. So we have 2 times negative 1 over negative 1, the absolute value of that. So the top is 2 over negative 1 or negative 2. Let's try one more to the left. F of negative 2, we get 2 times negative 2 all over negative 2. We're going to get positive 4 over negative 2 or negative 2. So we notice to the left, we are going to get negative 2. It's never going to hit this number, but it's always going to be this line here. Now let's go from the right. So the right of 0, let's just choose 1. We get the absolute value of 2 times 1 over 1. You will get 2. Let's try f of 2. We get 2 times 2, absolute value, sorry, it's a little messy. So 2 times 2 over 2, we get 4 over 2 or 2. So from the right, open circle, it is always going to be here. So just to kind of introduce approaching, or it did talk about that, how do you describe this? So we can say on the left, the limit as x approaches 0 from the left of absolute value of 2x over x is going to equal negative 2. Then on the right, the limit as x approaches 0 from the right of the absolute value of 2x over x is going to be a positive 2. So notice they're not the same number. So if they're not the same number, then therefore the limit does not exist. So I'll just put D and E for does not exist. So I think in the book, it's going to look for all of this information. What is the limit as it approaches the left? What is the limit as it approaches from the right? And then the limit does not exist. So try this example here. Find the limit of f of x as x approaches 3 from the left and from the right. So from the left, you would notice that you would always get negative 1. So you're looking at as x approaches 3 from the left of the right. So as it approaches 3, so you have to know what number are you trying to approach. So make sure you're reading that information there. So in the first example, just to go back, it was saying as x approaches 0, right? We know if we plugged in 0, it wouldn't work. And then here it is 3. So from to the left of 3 is going to be 2. So I plugged in 2 and 1, and anything to the left of 3, we would get a negative 1. To the right of 3, we would get a positive 1. So here is the information that it is looking for. What happens to the limit as it approaches 3 from the left and the right. In example 6, note that the function approaches different limits from the left and right. In such cases, the limit f of x as x approaches c does not exist. For the limit of a function to exist as x approaches c, it has to be true that both one-sided limits exist and are equal. So let's try another example, existence of a limit. If f is a function and L are real numbers, then the limit of f of x as x approaches c equals L. And this is true if and only if both the left and right limits exist and are equal to L. So let's try this example. Again, we'll graph. So piecewise function, we have 4 minus x when x is less than 1, and then 4x minus x squared when x is greater than 1. So this was, I think, all the way in the beginning of chapter 1 when we did this, so here we are again. So left of 1, so let's think about 1 here. And they're less than and greater than, so I know there won't be a solid point there. It's going to be open circle. So 4 minus x, let's graph that. So negative 4 minus x, that starts at 4. Our y-intercept is 4, and the slope is negative 1. So less than 1, so I know this is what my graph looks like to the left of 1. To the right of 1, this is 4x minus x squared, or x is great when x is greater than 1. So to the right of that asymptote, I'm going to rewrite this, negative x squared plus 4x. And so we know our y-intercept in this case is 0, so I know it's going to be here. And then if we factored out, let's just factor in a negative x minus 4, we know that the other one is going to be at positive 4 here. And then we know that it's a parabola open down, so it's going to look like this here. And again, this is only to the right, so here is our sketch, and then I'm going to erase this stuff on the left right here. That one. So here's a graph. Good practice in graphing these. So on the left side, okay, we graphed it. We can also plug in. Let's go ahead and plug in 1 and what's going to happen. And then we'll talk about it graphically as well. So if we plugged in 1 to this top one, we get 4 minus 1, which is 3, and that's actually where it hit at 3. And then same thing on the bottom one, 4 times 1 minus 1 squared. So that's going to be 4 minus 1, which is 3. So we notice that when we plug in a value, they approach the same value of 3. So we can say now that the limit of f of x as x approaches 1 equals 3. So try this example here. It's good practice to try and graph it, not only just plugging in the values, but graphing the piecewise function. And then find the limit as f of x approaches 1. So if you try this out, you would find, well, number 1, this is what your graph looks like here. And then you would find that the limit as x approaches negative 1, the limit of f of x as x approaches negative 1 is 2. So again, the limit exists because they both meet at the same value right here, as stated earlier. Here, for the limit of a function to exist as x approaches c, it must be true that both one-sided limits exist and are equal. Okay, so it does approach that same value. Let's look at a last example, comparing limits from the left and the right. For 2-day shipping, a delivery service charge $24 for the first pound and $4 for each additional pound or portion of a pound. Let x represent the weight in pounds of a package, and let f of x represent the shipping cost. Show that the limit of f of x as x approaches 2 does not exist. So just to get this graph here, this is another graph that we did in first semester, chapter 1. So let's graph this. 1, 2, 3, 4. And I'm going to break the graph because really I'm only interested in 24, 28, and 32. So I'm going to put $24 here. Just to give me some space, I'm going to name this 28. And then $32 here. Okay, so we know that it's $24 between when x is between 0 and 1. So notice 0 is less than. So from 0 to 1, and it's solid at 1. Then we look here at $28. It is $28 when x is between 1 and 2. So 1 open circle, 2 solid. Solid, open circle. And the last one at $32, we know that is when it's between 2 and 3 here. So it looks like this. And hopefully this makes sense to you that, depending on how much something weighs, like at the post office, if it's a little bit over, you're going to jump to the next price range, right? There's no like 28, or $29. It's just if it goes over, you're up in this range. If it goes under, you're in that range here. So let's take a look at this. Now we're looking at the limit as x approaches 2. So let's say the limit as x approaches 2 of the function, and we're going to say from the left side. So we're approaching 2 from the left side, it is going to equal $28, right? It's right here, $28. Now let's look at the limit as x approaches 2 from the right side. So we're looking at going to 2 from the right side, from here to here. What is it approaching as x approaches 2 from the right side? We are on this line here, and so it equals $32. Sorry, this f of x here. And it is $32. So because the one-sided limits are not equal, $28 does not equal $32, the limit therefore does not exist. The limit does not exist. So using this same graph here, show the limit as x approaches 1 does not exist. And so try this out. So if we try this out, the limit as x approaches 1 from the left is 24 and 1 from the right is $28. So really understanding what is the limit approaching, as you're approaching the value it gives you. And so we know that it does not exist here as well.